In this video, we'll be plotting numbers on the complex plane. And so you could even just pause the video now and try and just make sure that you can take these complex numbers and represent them geometrically on the complex plane. And I'm going to start walking through them, and you can check your answers with my work. So the first number, notice that there is no I in it. So this tells us that it's a purely real number, and it's going to lie on this axis. And since the real part is 2, we're going to start at the origin and go over 2. And then draw an arrow from the origin to that point, and we label it Z1. So then the next point is 2 plus 3i. So we're going to go over 2 again, but then this tells us that we're going up 3 on the imaginary axis. So that brings us up to here for Z2. And we draw our arrow to Z2. And so what you should be noticing here is that you can tell which sign the which quadrant the complex number will lie in based on the sign of its real part and its imaginary part. So if both the real and imaginary parts are positive, it's going to be in quadrant 1. If the real part is negative, but the imaginary part is positive, it'll be in quadrant 2. If the real part is negative and the imaginary part is negative, it will be in quadrant 3. And if the real part is positive but the imaginary part is negative, it will be in quadrant 4. So for Z5, both are negative. So we're going 1 unit back and 1 unit down. So this little guy will be Z5. And then Z6, notice there is no real component, so this is a purely imaginary number. It's negative 3i, so we're going to go down 3 units. And that'll be Z sub 6. And notice that each of these points in the complex plane has an arrow going to it, and so we can use that as a vector that describes its location in the complex plane. And so we can subtract like the vector of Z2 from Z3 to find another vector that will go between them and to find the distance between those 2 points. And so that's really all there is to drawing vectors in the complex plane. And just before I go, here's a quick summary table that tells you the sign of the real component, the sign of the imaginary component, and then what quadrant that will lie in.